In this lesson, we're going to look at the real number system. In algebra and in any math course, you talk about sets of numbers, and the real numbers is one of the biggest sets of numbers that we have. We do have something called imaginary numbers, which you'll learn later in this course or even in another course. But the real numbers comprise of what we call integers, which are signed numbers, fractions, decimals. Any number that you can write as a fraction is considered a real number. We have irrational numbers and rational numbers. And irrational numbers, like pi, we have approximations for. And we cannot write those as a fraction, but it's still considered a real number. It's just a number that we have to approximate a lot because we don't have an exact number for it. So the real numbers have a lot of different numbers that are part of it. So we're going to look at the different sets of numbers within the real number system. So a set is a collection of objects. We call -1 and 1 opposites of each other. To graph a number means to find and mark its point on a number line. The absolute value of a number is its distance from 0 on a number line. The set of natural numbers begins with the number 1, 1, 2, 3, natural because when you were young, that's the natural way to start counting. The set of whole numbers is the natural numbers, but it starts with 0. So the only difference between natural and whole is the number 0. The set of integers start including negatives. So it's pretty much the whole numbers and their opposites, but still no fractions, no decimals. And then finally, rational numbers, any number a over b, where a and b are integers. So any number that can be written as a fraction. So terminating decimals, repeating decimals, obviously fractions, whole numbers, because you can always put it over 1. All of those are considered to be rational. So when we need to convert from decimal to fraction or fraction to decimal, there's a couple things that we need to do. In this case, converting to decimal means when you look at this fraction, -3/8, you can think of it as a fraction, but you can also think of it as a division problem. So we can also think of it as 3 divided by 8. Now it's negative, so I know that my decimal will also be negative, so I don't have to worry about that. I need to go in here though and put a 0 in, a decimal point, and a 0 because 8 cannot divide evenly into 3, but it can divide into 30. Not evenly, but it can divide into 30, and 8 goes into 30 3 times. And that gets us 24, which leaves me with a 6. So I can add another 0 and bring another 0 down. 8 goes into 60 7 times, so 56. That leaves me 4. Tack on another 0, bring it down. 8 divides evenly into 40 5 times, because 5 times 8 is 40. So negative 0.375 is the decimal equivalent to -3/8. Now in these problems we're going to be looking and deciding whether something is less than or greater than. So 14 and -14. It's pretty easy when one number is positive and one number is negative to decide which is the larger number. So your positive number is obviously always going to be your larger number, or the number on the right is always going to be your larger number. So 14 is definitely greater than -14. 0 compared to negative 6. Well, 0 is greater than negative 6. Again, if you think of it on a number line, 0 is going to be on the right, negative 6 is going to be on the left. And again, the number on the right is always the larger number. It's trickier when you have two negative numbers. So I like to draw a number line, or you can visualize a number line. So if you start with 0 and you're going to the left, you're going to encounter negative 8 first, and then negative 9. So the number on the right again is larger. So negative 8 is greater than negative 9. If we look at the next problem, both numbers are still negative, so we'll say 0 is somewhere down here. I'm going to encounter negative 1.2 before I encounter negative 4.6. So negative 1.2 is my larger number. So it means negative 4.6 must be less than negative 1.2. Again, 25, one's positive, one's negative. That's the easy one. Positive numbers are always greater than. Now what's unique about inequalities, and actually it's not necessarily unique to inequalities because you can do it with equal signs as well, is that you can actually read them forwards and backwards. We can say negative 3 is greater than or equal to x, but we could also say that x is less than or equal to negative 3. In other words, I can read it with the variable coming first. Notice that my inequality symbol is still pointing to the x, so I didn't change anything, I just changed the way it was written. And we like to do that because we generally like our variable to be first when we're dealing with inequalities. So on the next one, 5 is less than y, that's the same thing as y greater than 5. And again, the inequality sign is still pointing to the same number, we're just writing it in a different form. Absolute value. If you recall, absolute value means distance from 0. So distance from 0. So if we have a number line, and we've got the absolute value of negative 16, think of 0, think of negative 16 all the way down here to the left. Distance from 0, well, what is the distance between 0 and negative 16? Well, it's 16, of course. So what this means is whenever you're dealing with absolute value, it's always going to be positive because it's a distance. So the absolute value of 12 is 12. The absolute value of negative 1/4 is 1/4.